Okay. So we are talking about measurements today. The whole chapter is not about measurements. And if you continually look at things sometimes in this class, oh no, not more math. The problem or the good thing, or just the relationships of chemistry and math, there are times where we have to calculate things. Well, in this case, it's not necessarily about calculations, it's about measurements. Different things are measured in different ways. So today what we're going to do is talk about what we're measuring and then the scale of that measurement. And a lot of it's going to be about the metric system, which I know does not sound very exciting. I'm not going to eat pudding today. Sorry, I can't always jazz it up like that. I can't have a whole week of feeling sick. But in the beginning, it's just about recognizing some units of measurement, okay? Like the worksheet, when you get the amount, I had a girl during resource just last hour, she finished the whole front in the first 7 or 8 minutes with the worksheet you get. You just kind of fill in, oh, this is a volume, that's a pressure. It's just getting familiar with some units, okay? So on the top of your note sheet, it says SI system of measurement. It means the international system. I know it should say IS then, but it's like System A International. So it's based on, not that. Uh-oh. It's all part of the show, people. All right, let's fill in what we're missing. So now I have no idea. Based on, is it metric? Is that what we're doing? Yeah. All right, here we go. It's based on the metric system. But there are some differences. So base units, there are, so you don't have to write this down, but just understand, like, normally you think, oh, it's grams. Well, we're going to say that that's actually not the base unit, and we've learned a little bit about Celsius and Kelvin, but the units that we're going to talk about, there's 7 of them, okay? And where do they come from? They're derived by basically natural phenomenon, which, if you're like, what is that supposed to mean? What it's basically referring to are measurements or observations that you can actually make. So what are things that you could actually measure in a lab setting or in nature in general? So these are the 7 big kinds of things that you can measure. And that's all this is for. This is a reference, okay? So hopefully you got the top part kind of filled out a little bit. Here we go. This is your first table. These are the 7 units, base units, meaning that they can change, okay? But these are the symbols, really important to notice. Not that it's a huge deal, but uppercase and lowercase, somewhat a big deal. I would never grade you like, ooh, you're lying on your K. It's borderline capital. It's not a big deal, but just kind of recognize like that's a lowercase, that's an uppercase. So M, you might recognize that or not. That is a meter. So lowercase m. I don't care that you write your m small versus big. Like this is not a capital technically, and that is a lowercase. We're not going to be that judgy about it, but if there are some clear differences, for the most part, it's nothing that you should stress out about. What is that? Okay, you can write all that you want, but I will underline the ones that are the most important. That's a length. Right? So when we're measuring lengths, the unit that we go to first is always meter. Okay, so any kind of measuring like that, that's the base unit for that. Anybody want to guess what S would be? Let me not show you. Be like, oh, that would make sense. Give me seconds. Why seconds? Why not minutes or hours? If you did a reaction, you're like, hey, how long was that? Oh, it lasted 0.004 hours. You're like, okay. What was the next one? 0.0039 hours. I don't know how fast or slower that was. So seconds makes a lot of sense. That's time, right? Nothing more to that. But seconds makes sense. Kilograms, whoops. And that would be what? Like the first one was time and length. That is, weight is almost right where, I know what you're saying of mass though, right? It's usually mass. I know I have amount, or we have amount of matter as well, but mass, right? If you're weighing something, oops, I just said it too. Taking the mass, you go, hey, we know this one. That is Kelvin, and that is temp. Yeah, potassium, nice. We measure things in time, length, and potassium. Those 4 potassium. Hey, my favorite abbreviation ever, because it's like I know you've said it before, but it's like I can't write the whole thing, so I will leave it as mole. Moles. I know that you probably like, I can do it, but I don't get it. Or maybe you're like, I don't know how to do it or get it. We're all at different levels still, but don't overthink it. It's the amount. If you can even start letting that process in your head. Well, wait, why wouldn't it be mass then? A mole is like the number. Like, hey, I want 3 dozen donuts. I didn't order it by mass. I didn't order 4.5 pounds of donuts. Or 4.5 pounds of donuts. All right, these are the ones we're going to be dealing with the most in chemistry, by far. But there are 2 more. One is ampere, which is capital A. If you take physics, for surely you're going to run into this. And what that is, that's current. Okay, it's not a huge deal for you now. If you go to AP chemistry, when we do electrochemistry, we talk about plating things like silverware. You actually plate. You cause the silver to actually get stuck on the metal, which is really cool. And you plated it, and you got to know how much current that takes. And then the last one, candela, which once I show you what it is, you'll probably understand more of why big cylinders with a wick in the middle are called what they are. That's light intensity, how much light is coming off of something. So a candle, a candelabra, things like that are dealing with light. So that's the base unit of that. Not candy, because candy doesn't fall under that. So these are some of our base units, okay? But there are some other ones that are derived. So this next table, what I'd like before we go, everybody have it? I'm moving on. I can't just touch that, can I? Derived units, they're mathematical. Oh, we like filling in lines here. They're mathematical combinations. What I need you to do, please, just make sure it's nice and bolded here, is that there should be a line right here. Because these are 2 separate tables, okay? This is not about memorizing this. This is about getting familiar with some units and measurements, okay? Because the more you see these, the better off you're going to be. So if I take something that is meters squared, that's like a length times a width. What is that? We know that one. Like length and width of this room. That is the area, yeah. So again, wait, well, why is this derived? Because those are 2 lengths, right? I'm taking 2 lengths. So I already used 2 things from everything that's from that first table. We're using them from the first table onto this table, okay? If I take 3, hope we agree it's volume. Please underline or highlight the liters there, though. That is going to be one, even though that's not the base unit, liters are used probably the most in chemistry because of the volumes that we're going to be dealing with milliliters and liters and flasks and all that stuff. Not all these you're going to recognize, but this one you may not, but like maybe this eventually you will. This is a mass over a volume. Mass over volume, it's a volume, cube. A mass over volume, liters. If it's how much you have, the amount of stuff, over how much space it takes up, that is what density is. And we're using units from the first table and making up new ones. Check this out. That's speed per time. What is that? Oh, I just said it, and I said that wrong. I was thinking of the answer already. That's distance over time. I gave it away. That's speed, right? Distance over time. Well, what would it be from the upper table? What do we have for distance? We use meter, and time is seconds, right? So that's why that's meters per second. Well, what about miles per hour? Those are American units. Please understand, when we talk about metric system, you're not a communist, okay? You're not anti-America. Okay? You don't have to like yell out America every time that you convert pints to gallons to quart. But the problem is, with our unit of measurement, it is confusing. How many tablespoons are in a teaspoon and a pint and a quart and a gallon and I mean, there's a lot of different numbers, right? They're not all equal. And it's confusing. It really is. America tried to go to the metric system, and it did not work. We do not like changes at all. You know, we like to know what 80 degrees feels like. Like if I said it was 28 degrees Celsius, we'd be like, do I need a jacket? Or not, like, is that hot? People like being a certain height. I like being over 6 feet tall. I don't want to be 1.9 meters or whatever. I don't know. I mean, is that, am I tall? I don't know. That didn't stick. Hey, I'm 29 kilometers from Chicago. Do I need more gas? Like, people did not want to change, so it did not fly. Although, let me not blow your mind, but I think this is weird. We buy our milk and pump our gas in what? What unit? Gallons. But you buy your soda, big soda, in some sort of conspiracy. Because liters are metric. I think that's weird. What about the smaller ones? Those are milliliters then. Well, they do have the fluid ounce. The smaller ones, I guess, are 16 fluid ounces. Whatever, but in 12-ounce cans. But the big ones are in liters. All right. A few more here. I can do this. Distance over time squared. Probably not going to run into this in this chapter, but if for your worksheet, just as a reference, it's good. This one we will. 1 over seconds. That's what this means. Actually, write this on the side. That's the same thing as 1 over seconds. Seconds inverse 1. Okay. It also is hertz. That's the other name for it. Hertz. That is frequency. Like on your radio, when you dial 101.1. 105.7, all those stations, that's a frequency. And it's how often the wave is hitting your antenna, and your antenna interprets it. And that's how we can dial it in. Don't worry about the 10th. You just did that one up there. That's not supposed to be there. All right, quickly up here. These are a little more physics, to be honest with you. Work and energy. That's kilograms times meter squared over second squared. I know, it's like, are you kidding me? You don't have to have that memorized. Don't freak out. Another unit is joules. That is the one we're going to use, though. So I guess, to me, the energy, underlying energy, and joules, that you will need in this chapter. But the work part, we're not going to look at as much. So, quick story, and I'm not going to tell it well because it's 10 years old now. Sometimes you just have moments of stupidity, or like saying something that you just wish you did. So I'm at Van Breedy's, and I'm buying a new TV with my family. I think I only have one kid at the time. I don't know how long ago this was. And they're trying to sell me on this surge protector, like the surge protector of all surge protectors. It was insane. It looked like it could run your whole house. And you just had way too many things on it. And he's like telling me about it, and this isn't that great of a story. I think. And he goes, and it protects from 14,000 kilojoules of energy in case you get struck by lightning or whatever else your house, whatever a kilojoule is. And I'm sitting there like, don't even do it. Don't. And I blurted out, oh, kilograms meter squared over second squared. And he stares at me, and I stare at him. And it probably was only 12 seconds, but if you're staring at somebody for 12 seconds, like I'm looking at you for like 1 second right now, it was really awkward. Finally, I go, so he's like, yeah, you're going to buy it or not? And he kind of clapped his hands, and he gave me the thing, and he just turned around and just walked their separate ways. I ended up buying it, and I walked over to my wife, and I'm laughing. She's like, what'd you do? And I told her, I'm like, she's like, why did you do that? I'm like, I don't know. Stupid. I wasn't trying to show off. It was just like, no, well, let me tell you. Like, who would care about that? Power. This we will not run into this year, but it's good to see, just in case this comes up. It's kilograms times meters squared over seconds cubed. But if you ever do see that, I'm not underlining that for you to underline that, but if you've ever heard of watts, I'm not JJ, a watt is amount of power. So your light bulbs, 60 watt, 100 watt, 75 watt, that's how much power is coming out. This one, I don't know why it's not hidden, but this one's actually really important for chemistry, and this is the one that you're going to want actually more. So underline that. So molarity, that's going to be big later this year. 3 more. Kilograms meters squared, or meters over second squared. This is more physics again, but it's a force. So Newton, you've heard of Newton before. They gave him some props by naming something after him, which is nice. If you're in physics, you're dealing with Newtons from time to time. Definitely. 2 more. Pressure. This, you will see this from time to time, PA. So if you underline that, it means Pascal. It's a scientist that worked on pressures. And then finally, ones that, if you ever run into it, just underline that one, because that's the one that you see more often in chemistry. I've never actually seen that unit in the middle, ever. I've never seen that. But I've seen voltage. Voltage is electric potential. If you're like, whoa, wow, that sounds fancy. A 9-volt battery has 9 volts. Like that. That's the electric potential it has. Once all 9 volts have been used, it's gone. That's the electric potential that it can do. Okay? So we're going to utilize that. It's all going to work out. So what's the whole point? It's these base units these symbols that are what our measurements are. But the metric system can help us convert from one to the next. Again, not like pint to quart to gallon. Like those are all different numbers as you're converting, 2s and 4s and 3 teaspoons in a tablespoon and all that. So you don't need to write this. I want you to understand the difference here. Mass and weight. If you're on, let's just say you weighed 80 kilograms, regardless. It's just good to look at. There's no spot to write this. That's how much stuff you have. It's how much stuff you have, no matter where you are. So if you're on the moon or the Earth, your mass is 80 grams. But I hope we'd all agree, if I'm on the moon, I'm going to weigh less, right, than on the Earth. It's about gravity. So weight is about mass and a force. That's why there's newtons. It's the force pulling you down. So that would be 176 pounds on Earth, but I would only weigh 29 pounds. I still have 80 kilograms of stuff. So don't ever, it's fine if you say it once in a while, like, I'm going to go weigh that. But these balances are calibrated to our gravity at this here. So you're basically getting the mass, not the weight. All right. Excuse me. All right. Prefixes. Power of 10. I think that's supposed to be on the top. Power of 10 value in relation to a base, root, or unit. We're going to do something that will help you out a lot. Let's get these down first. You need to know prefixes. A prefix is something that comes before right? Like a pre-game or a pre-show. It's before whatever's happening. So it's before the base unit. And we're going to learn roughly 12 of these. I don't know off the top of my head how many there are. A lot of them you've already heard. A lot of them link to like technology. So actually, I'm going to go down to the K first. So K means kilo. So if you've ever watched a drug movie or a mob movie, they might have this in their trunk. They say, well, there's a kilo. And they might be talking about an illegal substance. It'd be a package of maybe like cocaine. And why do they call it that? Because it'd be 1,000 grams of it. 10 to the third. 10 times 10 times 10. I'm not saying that cocaine is good, just because I say the word. Okay, so that's 1,000. Then we move up. M, 10 to the 6th. So 10 times 10 times 10 times 10 until you get 6 of them. That is a million. M does not mean a million. Anybody want to guess? It's a pretty common prefix. Mega, like a megabyte. So I'm going to date myself pretty badly here of how old now I am starting to become. When I was in college, about halfway through the flash drives, thumb drives, whatever you want to call them, first came out. I have it somewhere here. I know you know what they look like. It's not the point. Shoot, I don't have it. I have the actual one I'm talking about. This one. I thought this one had size. I got a 500 megabyte. It wasn't even that. It was 250 megabytes. So a quarter of a gig. And now, before I tell you the price, you can get a 16. Let's just get to the other one. A giga, right, is a billion. You can get a 16 gig flash drive for like $8 at Office Depot. I think 16 gig. I had 250 meg, and it costs $120 for 250 megabytes on a flash drive. And now, like 100 times bigger, and it costs like $8 at Office Depot. My first computer I ever bought at college, I went to Home Depot or Best Buy, and I got the biggest computer I could buy, like the nicest one. It was a Hewlett Packard. It was a 6 gig computer. Like that laptop I think is 40 just by itself. After it was formatted, it was like 4.7 gigs. It cost $2,500. It's $2,500 for 6 gigs. Like my phone's bigger than that now. It blows my mind how fast it's going. So that's Giga, 10 to the 9th, and then the last one, I just bought an external hard drive a couple years ago. It's a 2 terabyte hard drive, which that was only like $100, which really makes me laugh because that was cheaper than my flash drive of 250 megs. A terabyte does not mean trillion, but it ends up being right million, billion, trillion. So 10 to the 12th. So those are larger prefixes. Okay. There are a couple other ones, but those are the ones that you're going to use the most. 10 to the 2nd would be 100, right? 10 times 10. And H is hecto. You're not going to run into this as much in chemistry. 10 to the first is still 10. If that confuses you at all. And that's deca. So that's the front side. Flip it to the back. Now, it doesn't quite say this, but it's good enough. Where I think it says the word various. Is that true? I think. Please right above that base. So this would mean there's no prefix. So actually, if you can write that anywhere on there on the side, there'd be no prefix here. What's a prefix? I still don't get it. It'd be a letter in front of a measured unit, like a kilogram. That's 1,000 grams. Kilo's 1,000. Gram is my measuring unit. All right, so these get smaller. As you notice, 10 to the negative whatever. So 10 to the negative first, I'm moving the decimal now to the left instead of to the right. Like here's 10 to the first, I move it to the right. So that's a tenth. And a few of these you might not have heard of, but most of these you have, I guarantee you. I bet 9 of these you've heard of. This is deci, you may not have heard of this one. The next 2 I know you've heard of. No way you've heard of it. So each one, if I'm moving down by 1, it's just moving the decimal one more time, so that's 100th. Right? So C is if it's 100th of a meter, like on here, I have 100 of these on here. On 1 meter is my base unit. So if I put a C in front of the M, it becomes a cm, and that becomes centi, right? Centimeter. That means there's 100 of those, like century. There's 100 of these in my meter. And then inside that, there's 10 of these. So if there's 10 inside of one of those, then there's 1,000 of these. So little m must be meaning 1,000th. And that's a milli, right? So a millimeter, there's 1,000 little millimeters in this stick. Maybe not anymore, I burned off probably too. But still close. Now we get to a few others. I drew it on here, you don't need to redraw it. If you ever see a weird letter and you're like, what's that letter? I don't get it. It looks like a weird U. It's called mu, which I'm not making that up. We're out of M's. We have capital, we have lowercase. Can't do anything else with it. So this, if you go 3 more, so if this was 1,000th, that would be a millionth. So that's, and we have spaces here, so you can kind of easily see how many zeros you'll need. That is called a micro. And you're like, whoa, like microwave? Exactly like microwave. Microwaves use wavelengths a millionth size of this, a millionth smaller than this. And that's how it cooks food. More practical, well, that's pretty practical actually. But another way that microwaves are used is radar. It's used, that's what radar is. And it's not used to cook your hot dog out in open air or anything like that, but that's what's used for that. 2 more, probably, or Apple came out with, I don't know how many years ago already now, but this is a billionth. So that'd be nano, the nanopod. I guess they don't call it the nanopod. If I said it out loud, it doesn't sound right. It's just the nano. They should have called it the nanopod. And I'm waiting for one day when Apple comes out with this guy right here. So this is a trillion. Hey.
Thanks. You got like the answer sheet for this guy? He was something else to do this. Like where they fill out the answers.
Oh, they did it.
Thank you.
So I'm waiting for Apple to come out with the Pico. Maybe that's embedded in your earlobe or something. You just flick it, something like that, or inside your pinky finger, and you just snap and change yourself. Okay, what I would like to do before we go into this, hopefully you can see you have this space where it says conversion factors. And there's like a space right there. What I'd like us to do, we're going to do this together, make a line the whole width of your paper. If you don't want to do it there, do it all the way on the bottom of your sheet, one or the other. But do a line all the way across. Smack dab in the middle. Put a 0 right in the middle. And then, what I'd like you to do, before I tell you what else, you can do this on your own right now. I want 12 lines on each side, so space it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Put 12 on each side. Then, label them the way I'm doing it. Every 3, we don't need to write every number. Every 3, put a power that increases by 1,000. So 10 to the third, 10 to the sixth, 10 to the ninth, 10 to the 12th. Every third. We don't need to write every one of them. That's overkill. We don't need to write 10 to the first, 10 to the second, 10 to the third, 10 to the fourth. On the other side, do negative numbers. Okay? Now, you're like, what's happening here? I'm going to show you how to convert values two different ways. You can do it mathematically or you can do it more visually. And whatever works for you. Everyone's different. But hopefully one of these kind of clicks with you, okay? I'm going to fill in all of my prefixes. So you have the table, half of it's on that sheet, the other half's on the other. So I'll do the one on this side. So 10 to the 12th is a capital T. 10 to the 9th is a giga. 10 to the 6th is mega. 10 to the 3rd is kilo. So on and so forth. We can keep going through. Well, we have the rest of them, right? We have H and DA yet. So this is H. This is DA. Please fill in the other ones on the. You have them right above you. Put them where they're supposed to go. And so, for example, this is D. This is C. Just look right above. I'm putting these letters on those numbers. You can fill in the rest. I'll give you 30 seconds to just fill those in. You got nano, you got pico, you got micro. Place them where they're supposed to go. Besides a few of them, they're every 3. So that's what's kind of nice about this. Okay. I'm going to show you how to use this right now, okay? So, do we have it all? If not, you have what you need up there. I'll bring that back up. Okay, so when we do a conversion in a T-chart, we always place a 1. I'm going to show you how we can do this. With the prefix unit, then place the power of 10 value, I guess. I don't know why there's 2 spaces. That's the other spot for you writing. I'll show you how that's used. Don't worry about what it says in the example. I'm going to show it to you right now, what we're going to do. There's 2 ways. Some of you might laugh at one way or the other, like why would I do it that way or why would I do it the other? That's great, then that your brain's clicking one way, and that's good, as long as something looks like you might be interested in doing it in that fashion. Okay, so let's take a look. Here's the first one. I'm going to show you the math way first. Okay, so if I have, just put this underneath. That many kilograms. And now I know I draw a T-chart because you're like, no! T-charts are only meant to help organize converting. What it does for us is it makes us have to put units on top or bottom and just keeps it organized. Okay, here is where you have to follow a very specific rule though. If I look at above, it says always place a 1 with the prefix. This is my prefix. So I just put a 1 there. Then it says, place the, I don't write it down, power of 10 value with the root unit, the base unit. So what is the number with K? Just look at your number line or on the front, either one. It's 10 to the 3rd right now. You could write it like that. Just want you to understand, this could also work. I'm just rewriting it to show you. You could also say there's 1,000 of these in there, 1,000. That's what that means, 10 times 10 times 10. But I'll tell you now, there's not one of you probably want to write 1,000,000 or 1,000,000,000 or 1,000,000th. That's what the exponents are there for, us. And then we multiply it. So you're multiplying it by 1,000, right? So I learned a long time ago, however many zeros there are, that's how many times I move my decimal right or left, right? If it's just multiplying by 10 or 100 or 1,000, so it becomes how many grams? Okay. Well, let me show you a different way. We're going to stay on the same problem. I'm going to do this every time just to show you, because some of you might like this better. It's not ideal, but either way you have to know certain numbers. You're going to find out like maybe this one and that one may not show up that much in chemistry. But besides that, they're all on a power of every 1,000. Check it out. If I'm at kilogram, it's a K, I'm starting at kilogram, and I want to end at gram. Where's gram? There is no prefix, right? There's nothing there. So that means there's no prefix. That's the base unit. How far away is that? 1, 2, 3. And which way am I going? I'm going to the right. So I literally take my decimal and I move it 1, 2, 3 to the right, and there's my number, instead of doing a mathematical conversion. Now if you're like, oh, it's a horse apiece. Well, let me show you the next problem and see if you still feel like that. All right. Here we go. Centimeters to millimeters. Let's do the other way first. If I did this, I'm starting here and I'm ending here. What direction do I have to go? Right or left? To the right. How many times? 1. So I literally take this and I do that, and my answer is that. I don't think that's that right. You do this. I would like you to have this down because it's important. The classes are learning how to do this today like this. So what do I have to do? Here's the potential confusing part for you, is that I need to say how many meters are in centimeters. What's our rule? Always put a 1 with the prefix. Always put the number that links to that prefix here. So that's C, so it's 10 to the negative second. I'm not at the unit I want millimeters. So I have to bring this down. What do I always do? I put a 1 with the prefix. What is milli? 10 to the negative third. Anybody leaning towards one direction, which way they like it? I don't need to hear it. I just wonder if you're feeling that way. So how do you calculate this? On my calculator, it's 10 to the x. So it's a 10 to the x button. So you just have to put that in there. But this is the answer. I'm just moving the decimal 1 to the right. That's what this shows me. But if you ever were asked to do it mathematically, we just need you to get to answers one way or the other. As long as they're your answers, you'll do very well. We're going to do one more yet. We're going to move down, letter C. So it's still just move it 1 to the right.
I have a question.
Yeah.
Okay, so when you moved it, never mind.
You sure?
Yes.
What?
But I'm saying, yeah, I think that's supposed to be that. Yeah. Should the zero be gone? Yeah, the 0. Okay. I was gonna say, put it at another place.
What? It's awesome. Sorry, 11th mod and 12s. They have to watch this next hour. I messed up. I have to go to a meeting, so put this red box. Nice. Nice work. Okay, let's look at the next one, and hopefully I won't make a mistake. Prove that I know what I'm doing here. How many times, just looking at that, how many times do I have to move it in what direction? Just the decimal, just by looking at my number line. So you're looking at mega and kilo. I'm moving it 3 times to the right. Correct? I'm just looking at that. So you could just move that decimal. Wait, there isn't a decimal. I hear what you're saying, but it's basically right there. Right? Even if it's not there, it's there. So I go 1, 2, 3. What goes there? Zeros. I know I'm doing this one right. So it becomes 23 million. Done. Let me show you the other way. So I have to put megawatts to watts, and then watts to kilowatts, If you're like, why can't you just put kilowatts over megawatts? You probably actually could do that. You just have them equal each other, but I'm just trying to show you what the other classes are also being taught. I've never taught it this week. So we put a 1 with the prefixes, and then we put the 10 to the whatever it's supposed to be of that one it's associated with. So mega is 6, kilo is 3. What is confusing, I'm sure, for some of you is the very fact that why am I putting it on the one that isn't linked to that, right? Because 1 megawatt would equal 10 or a million of my watts. There's a million watts in 1 megawatt. So I would multiply it by 10 to the 6th, divide it by 10 to the 3rd, and guess what? That's the answer. I'm moving the decimal 3 times. Okay. So what we're going to do, I do have a little fun, 2 little videos to show you about the power of 10, if we have time. Some hours are seen and some aren't. What they do in this video is they take a picnic that's in Chicago and they move back, multiply it by 10 each time. So first they go by a meter and then 10 meters and then 100 meters and then they go into space. Oh, thanks. Type issue. Let's take a look at the worksheet first. No, that's why I'm doing one. All we're trying to do, it's almost like overkill. It's really quick. It's not difficult to do. If you can, writing at least the prefix would be nice. But it says prefix and root. So the prefix is milli, and you always kind of put a line at the end. If you're just going to put an M, unfortunately, that would mean meter. So we do need you to write out the prefix part. And then what's the root? You can write mole. Okay? If you want to shorten it up, you definitely can. I'll do one more for you, just so you're understanding. Number 5. So what was that? 1. Let's go down to 5. That is NS. So what's my prefix? Nano. So I write nano. You have it on your reference sheet. What's my root? Seconds. And if you want to just, I don't care if you abbreviate a little bit, but don't just write S. But look it up. It's on your sheet somewhere. Okay? So that's how you do the first part. Already, I hope that you feel like, okay, I can definitely handle that. Next, let's just take a look at the next part. A. Again, what you need to do is look at your sheet if you're not sure. All we're asking you guys is what does it represent? So mass over volume, grams per milliliter, it's asking for this part. The number doesn't have any meaning for you right now. That is a density. Let's do one more, just so you are with me on this. Let's do this one. That's G. I want to do G. Okay, just because it has a prefix doesn't mean it should throw you off. This is what matters. And what is that? That is time. That's a microsecond. Okay? So please be aware, you're trying to look at what is the measurement. Like what are we actually measuring? So that'll get you started.